So we're solving systems of linear equations. Videos have already been posted for how to solve by substitution and solving by elimination and solving by graphing. And so this isn't another way of solving a system of equations, but it's just what happens with special cases. So remember that a solution must be a point, which is an ordered pair, which is of the form of x, y. And we can check our solutions by substituting our point, our values for x and y back into our original equation. But what happens in special cases? So some special cases are when you get infinite solutions or no solutions. So infinite solutions occur when the two lines are actually the same line. Okay, so if the two lines are actually the same line, you're going to have infinite solutions because every point would be in common with both lines. Therefore, every single point would be a solution. And because lines continue infinitely, there would be infinite solutions. So you're going to know this is true if you simplify your equation and you have the exact same numbers on each side of your equal symbol. Now, that's when you're actually solving. That's not when you're checking. You should always get the same numbers on each side of your equal sign when you're checking. But when you're actually solving, you're going to get, if you simplify it all the way down and you get 2 equals 2 or x equals x or 8x equals 8x, then there's not much you can do other than just know that you're going to have infinite solutions. So no solution is going to be the second, and no solution happens when two lines are parallel to each other. Parallel lines have the same slope and different y-intercepts, and therefore they will never, ever, ever intersect each other. So if you're looking for a point that would satisfy both equations and the lines never intersect, there's never going to be a point. So this is going to happen when you simplify your equation and get an untrue statement when solving for a variable. So if you get that 0 equals negative 20 or 2x equals negative 6x. So infinite solutions, let's just look at one equation that could happen. And if I see a question like this, hopefully you would say, oh, substitution would be the way to go. And that's simply because I have one equation in terms of my variable of y. So I have y equals 2x plus 4. And if I substitute 2x plus 4 in for y, I would get that 2 times 2x plus 4 equals 4x plus 8. Okay, so now if I distribute, I have 4x plus 8 equals 4x plus 8. I can see I have the exact same thing on both sides of my equality symbol. But if I go ahead and try a little bit farther to solve this, because I haven't realized it yet, and I subtract 4x from each side in hopes to get my x's on one side of the equation, I'm left with 8 equals 8. And this is a true statement. That's true. And if I would have subtracted my 8's, I would have been left with 4x equals 4x, which is also a true statement. So when solving my equations and getting a very true statement, but not much that I can do with it, I would see that these two equations are actually the exact same line, and I would have infinite solutions. So that is one possibility. Okay. My next equation is going to be, or my next set of equations is going to give me a no solution answer. Okay, so again, if I look at this, I have y equals 2x plus 6, and I've got y equals 2x plus 8. And if I want to solve for this, again, I would say, hey, these are both actually in terms of y, so let's substitute one for the other. So if I substitute 2x plus 6 into this equation, whoa, that was ugly. Sorry about that, guys. Into this equation for y, I'm left with 2x plus 6 equals 2x plus 8. Okay, so if I subtract 2x from each side here in hopes to get all my variables on one side of my equation, I'm left with 6 equals 8. Well, 6 doesn't equal 8. That's not a possibility. And so because this is an untrue statement, I have that there is no solution here at all. No solution. If I graphed this, I would see that I would go up 6 and put a line, and then up 2 over 1, up 2 over 1, up 2 over 1, so I would have a straight line through here. Well, if I did the same thing for my second equation, I would go up to 8, and then I would have the exact same line. And so if I graphed these on the same coordinate plane, I would see that these are indeed parallel lines, and they will never intersect, and that's why I don't have a solution.